Welcome to Golang for Devs. Let's talk about types. There are a bunch of ways to declare and initialize variables in Go. You can use package level vars, which are accessible everywhere in the package. You can use the var keyword in a local scope, like inside of a function. And Go also supports type inference, so you can drop the type if you assign a value to the variable. Lastly, there's another shorthand that uses type inference, but note that you can only do this in functions. So you can't use it as a package level variable at the top of the file. Okay, each type in Go also has its own distinct zero value. So if you declare a variable without assigning it to anything, then Go will automatically instantiate it with the zero value for that type, which for an int is just 0. You can also cast types in Go. So if I have an int 8 and I want to turn it into an int, you just list the type you want to cast to, followed by the value you want to cast from in brackets. Okay, let's talk about actual types. Broadly speaking, there are two categories of types in Go. Value types are types that store data directly, and when you pass them to a function, the actual data or the value is copied. In contrast, reference types just store a reference to some underlying data, like a pointer. So when you pass a reference type to a function, only the pointer data is copied and not the actual underlying data, which is important because if you modify a reference type passed into a function, you'll be modifying the original variable as well. Okay, ints. So there are 5 signed integer types in Go. The first 4 are an 8-bit int, a 16-bit int, a 32-bit int, and a 64-bit int. The last one is just a regular int, which is either 32 or 64 bits, depending on the system architecture. In practice, you should just use an int most of the time because it matches the CPU's word size, which gives you a small performance win, and it's considered more idiomatic Go code. Lastly, there's also a special rune type, which is just an alias for an int 32. A rune in Go is the same as a character in other languages, and it uses an int 32 because that matches the max size of a UTF-8 character. Okay, unsigned integers. So like ints, there are 5 types of unsigned integers: an 8-bit, a 16-bit, a 32-bit, a 64-bit, and just the regular one, which again is 32 or 64 bits depending on the architecture. And like with ints, it's best practice to just use uint when you can. They also have a zero value of 0, just like ints. And there are also a couple of special types that are just aliases for uints. The first is a byte, which is an alias for a uint 8 and represents a byte as a decimal number. The second is a uint pointer, which is an alias for a uint and can hold a pointer address. In practice, you won't be using a uint pointer unless you're doing super low level stuff, so you don't really need to worry about that one. Okay, floats. There are only 2 types of floats: a 32-bit float and a 64-bit float. Both types follow the IEEE 754 standard for floats, so they should behave similarly to floats in other languages. And like ints and uints, the zero value for a float is just 0.0. The most important difference between a float 32 and a float 64 is that a float 32 has 24 bits of precision, which maps to 6 guaranteed significant digits in a base 10 decimal number, while a float 64 has 53 bits of precision, which maps to 15 guaranteed significant digits in a base 10 decimal number. So you can pick whichever type gives you the precision you need. And one last thing, if you don't specify a type, then Go will treat a decimal number as a float 64. The last basic numeric types in Go are complex numbers for working with imaginary numbers. So a complex 64 is stored as two float 32s, one for the real part of the number, one for the imaginary. A complex 128 is stored as two float 64s, which add up to 128 bits. And if you don't specify a type for these, Go will treat it as a complex 128. Like the other number types, a 0 value for a complex 64 or complex 128 is 0 plus 0i. Okay, lastly, you can extract the real and imaginary portions from complex numbers using the built-in real and image functions. Okay, the last basic type in Go are Booleans, which are super straightforward. So the syntax is just like this, and a 0 value for a Boolean is false. And that's everything you need to know about how the basic types work in Go. If you found this fast and clear and helpful, throw it a like, give a subscribe. I'll cover more complex types in future videos, so stay tuned for those. And if you want access to the code examples, the link is in the description. Until next time, keep breathing and keep building.